exercise number 8 is going to be similar to exercise number 7. There's going to be a little bit of difference, but we'll go ahead into that. They ask us to find f of x, and they give us a few values, and f of 0 equals 1 is the first. The second one is f of 1 equals 0. And then the third one is f of 3 equals 5. And then the problem tells us f is quadratic. So just like we analyzed in the exercise number 7 resolution, here we're going to look at the key pieces of information that the problem is giving us. And in this case, the fact that f is quadratic is the most important element that is going to help our solution. So the fact that f is a quadratic function, or a quadratic equation, that means that we have to use the general representation of what a quadratic function is, which is ax squared plus bx plus c. This is the general representation of a quadratic equation, just like we had a linear representation in the previous exercise. So all we have to do now is evaluate the values that the problem gave us in the quadratic function that we have right here. We have values for x, 0, 1, and 3, and we're going to plug those values into the quadratic function that the problem is also telling us right here. So let's start with f of 0. F of 0 is going to be a multiplied by 0 squared plus b times 0 plus c. That is, again, simply replacing or evaluating 0 into f, and f being a quadratic function. 0 simplify, because 0 squared is 0, b times 0 is 0, and we're all left with f of 0 equals c. And as you have noticed, here's where the key important of the initial exercise tells us. F of 0 also equals 1, so we can make that assumption and conclude, therefore, that c equals 1. It's the same actual thing. See, f of 0 equals 1, and it also equals c. Therefore, c equals 1. Therefore, what we have to do next is rewrite the quadratic function from our general representation. So in this case, we're going to have f of x equals ax squared plus bx plus 1. So all we did was replace the value of c with the solution of c equals 1. And now all we have to do left is evaluate the other two values. F of 1 is going to be equal to a times 1 squared plus b times 1 plus 1. Again, simply replacing the value of 1 in the x of the quadratic function. So evaluating or doing the arithmetics, we're going to have 1 squared is 1, so we have a plus b times 1 is 1, a plus b plus 1. Again, simply evaluating. And all we have to do next is follow up with the information that the problem gave us at the beginning. And it's f of 1 equals 0, therefore a plus b plus 1 equals 0. And this is going to be our first equation in the system of equations that we're going to use to solve the remainder of the problem. Next comes f of 3. So we rewrite f of 3 is going to be equal to evaluating 3 in the quadratic function. And we can use also the one that we said before. So f of 3 is going to be equal to a times 3 squared plus b times 3 plus 1. Therefore, f of 3 is going to be equal to 3 times square is 9, so it's 9a plus 3b plus 1. And just like we did before, f of 3 also equals 5. So we're going to make this equal to 5. Therefore, 9a plus 3b plus 1 equals 5. Okay? This right here is going to be our second equation for a system of equations that we're going to use to solve the problem. Okay? So we put this aside. And now we're going to rewrite a. And this is going to be a plus b equals minus 1, putting the numbers on one side and the variables on the other side. And for the second equation, same thing. We're going to have rewriting 9a 9a plus 3b equals 4. Getting rid of the 1, putting it to the right side of the equation. This is our system of equations. And just like we did in the prior exercise, all we have to do is solve. Okay? How do we solve? We can do addition, subtraction, substitution, whatever method you prefer. We can simply get rid of the b, again, multiplying by minus 3. So I think that's a fair statement to do. Let's rewrite the system of equation. Again, a plus b equals minus 1 for the first one, and 9a plus 3b equals 4. And similar again to the previous exercise, we have to get rid of one of the two variables. So let's multiply by minus 3, and that will give us minus 3b on top to get rid of. So let's solve that. System of equation is going to be minus 3a plus or minus 3 times b equals minus times minus plus, so it's going to be positive 3 on the right side of the equation. Here we go. And the second equation is going to be left unchanged. We only affect the first one, so 9a plus 3b equals 4. And all we have to do is solve this. Minus 3a minus 3b equals 3. 9a plus 3b equals 4. And you can see here how we can easily get rid of the b in the part of the dual system equation. So cancel each other out, and all we have to do is add the equations. So we're going to be left with 6a, because 9 minus 3 is 6, equals 4 plus 3 is 7. So 6a equals 7, therefore a equals 7, 6. And there is our value of a. Therefore, all we have to do next is solve for b. Plug a into any of the equations. Let's use the first one. So we can do a plus b equals minus 1 and substitute value of a for what we found. Therefore, 7, 6 plus b equals minus 1. And just here, we have to get rid of the b. b equals minus 1 minus 7, 6. Let's rewrite minus 1 as 6, 6 negative minus 7, 6. And therefore, we add same denominator. And b is minus 13, 6. And there we go. Now we have c, we have a, and we have b. So all we have to do left is simply rewrite our original quadratic equation, our original quadratic function, with the values that we found. Therefore, f of x is going to be equal to 7, 6 x squared minus 13, 6 x plus 1. And there we go. That is the function that they were looking for.